Okay, good afternoon. So there are some rules for how the derivative relates to the graph of the original function, or equivalently how we can glean information about the derivative from the graph of the original function. Particularly if the function is increasing, the derivative is positive, and vice versa. If the derivative is positive, the function is increasing. If the derivative is negative, the function is decreasing. If the function is decreasing, the derivative is negative. If the derivative is 0, that means we have a horizontal tangent line at that x value. So we start here, right? The lines I drew here, this line, this line, this line, they're all horizontal tangent lines corresponding to slope 0, the graph of slopes, the graph of the derivative. And if the function was increasing, right, on this interval, from this horizontal tangent line to this horizontal tangent line, the derivative is positive here because the function is increasing. Here, from minus infinity to this horizontal tangent line, the function is decreasing, so the slope is negative. From this horizontal tangent line, from this horizontal tangent line, the next horizontal tangent line, again, the function is decreasing, so its derivative is negative. And beyond this horizontal tangent line, the derivative is positive because the function is increasing. Okay, so those are the rules we need to know for now. That's just for the first derivative. There'll be some more stuff we can talk about later. Now, you can also talk actually about the second derivative. That is the derivative of the derivative. F prime of x, the second derivative, written with 2 primes instead of 1. So the limit as h goes to 0, f prime of x plus h minus f of x, all of h. So notice here we have the graph of f prime. We could also, if we wanted, go here and graph delta. So that'd be the slope of this derivative function. As we see, okay, the derivative function has a peak here, our horizontal tangent line here, here. So let's here. So these 3 points are where f delta prime has to cross the x-axis. So again, it's going to be, because f prime is decreasing, the function is decreasing. And it's here, start increasing again, stays increasing to here, starts decreasing until we get here. And so that's when we're down here. That's where the second is. 0 here, 0 here, and then it's going to increase. It's going to be positive. So between these 2 values, because f prime is increasing, the second derivative is positive. Between these 2 values, where f prime has a horizontal tangent line, the second derivative is negative, and beyond that, second derivative is positive. So we'll get more into the second derivative a little bit later. For now, just know that this is how it's defined. It's the prime. So it is the derivative of the derivative because the derivative is a function. So let's actually go over a few examples. Let's say f of x is square root of x. F prime of x we can compute this limit. Right? 1 over 2 square root of x. So this is just a computation. You probably will see, you're going to see a problem very similar to this on your WebAssign homework. But the point is we start off with a function. We're able to use the limit of the difference quotient to compute its derivative, which is also a function. And then we do this one more time. Here, and multiply both numerator and denominator by the product of these two denominators. X. Alright. When h goes to 0, square root of x minus square root of x plus h, divided by 2h times square root of x times square root of h. Let's do this again. Still need to multiply this. Square root of x plus h. Square root of x plus h. X minus cancel. What are we left with? You plug in h equal to 0, we get 2. this is square root of x times square root of x times 2 square root of x. So this actually ends up being negative 1 over 2. This becomes just x, square root of x times itself is just square root of x. Square root is x times 2 square root of x, which is equal to negative 1 over 4. X times root x is the same as x to the first times x to the 1/2 is the same as x to the 3. So the second derivative here is going to be the function negative 1 over 4. But there's an important piece of information here, detail that we sort of glossed over when we defined the derivative as a function. What's the domain? If you recall from the very beginning of class, the domain of the function square root of x is 0 to infinity. But we include 0, sideways stable, because you can feed square root everything except negative numbers. Here, square root appears in the denominator. You can feed this everything except 0 and negative numbers. So the point we should take away here is the domain of the function and the domain of its derivative need not coincide. In particular, the domain of the derivative, we'll see this, we'll see this later on in differentiation rules, could have x or a function of x in the denominator. So that means 0 could be the domain of the original function, but it might not be the domain of the derivative. Now, there's just, so what could this represent? What's an interpretation of this? Well, the function, so if the function, let's say the function represents distance and x represents time, we saw this before, right? H of t is height. On the eraser, t seconds after it was dropped. What's h prime of t going to be? It's going to be the velocity of the eraser. And h double prime of t is going to be the acceleration. What are the units for this? These are in feet. These are in feet per second. And this is in feet